Okay, so let us start with the today's topic, that is network layer. So network layer is the third layer in OSI model. So we have studied the OSI model, so in which we have studied the 7 layers of the OSI model, as these layers are written as okay. So these layers are written as application layer, presentation layer, session layer, then transport layer, network, data link, and physical. So you should remember this APSTN, DP. So A for application, P for presentation, S for session, T for transport. Then this is a network, data link, and finally physical layer. So till now we have studied a physical layer in the first unit, then data link layer in second and third unit. Now we are in the fourth unit, so we are about to start with the network layer. So network layer is the third layer in OSI model of computer networks, and the main functionality of the network layer is to transfer network packets from source to the destination. Network packets from source to the destination. So it is said that network layer deals with point-to-point delivery, or point-to-point, or it is also called as end-to-end delivery of data. So it will start from a source node. So let us say this as a source and this as a destination. So there will be intermediate routers or network connected through which this data will pass, and finally it will reach to the destination. So this particular protocol deals with the end-to-end delivery. So it will first transfer from this node to this node, then from this node to this node, and then from this node to this node. So this is called as the end-to-end delivery of data. So network layer mainly deals with delivering packets from one end of the network to another end of the network. One end of the network to the another end of the network. So this is the first end of the network. This is the last end of this network. So this will be, this is network 1, this is network 2, and this is network 3. So second time it will be started from one end of the network and will reach to the another end. Similarly, this network 3. So this network layer deals with end-to-end delivery of data. So the features of network layer are: main responsibility of network layer is to carry the data packets from source to the destination without changing or using it. So without changing packet, it transfers data from a source to the destination. The packets are too large for delivery, they are fragmented. The another feature of network layer is, as the packets are very large for delivery, so that's why they are fragmented or broken down into smaller packets. So this packets network layer receives this packet from first packet data is generated by application layer, then it is delivered to a transport layer, and from transport layer it is delivered to a network layer. So this application layer adds a header, this transport layer adds a header to this data, and then again the network layer adds a header to this data. That's why the packet size becomes large, and in order to transfer those packets, it requires to be fragmented or broken down into smaller packets. Then it decides the route. It is not route, it is ROUT. It decides the route to be taken by the packets to travel from source to the destination among the multiple routes available in a network. Okay, for example, say if you draw a network, this is let us say source, and this one as destination. So in between source and destination, there can be multiple routers available like this. Okay, now for transferring a data can travel through this as one of the route. this node to this node, this node, this node, and this node. Then data can travel like this also, or data can travel like this as well. So there are multiple routes available for data transfer. So which route is to be selected is decided by this network layer. So for deciding routing path, there are different routing algorithms like RIP, Routing Information Protocol, EIGRP. That these protocols you are going to study in detail. For now, just remember the names: RIP, EIGRP, then BGP, OSPF. The BGP means Border Gateway Protocol, OSPF, Open Shortest Path First Protocol. So these are all the protocols that are used for deciding the routing path. So this is another functionality or feature of the network layer, that it decides which route through which data will travel. Then the source and destination addresses are added to the data packets inside the network layer. Now, this is the important feature of the network layer, is that it adds source and destination address. So this source and destination address are called as the logical addresses that are added by the network layer. In data link layer, physical layer, we have studied that data link layer and physical layer deals with the physical address or the MAC address. Now this network layer adds two additional addresses. These are called as the logical addresses, or also known as IP addresses. IP addresses. So it adds the source address, that means who is sending the data, and destination address for whom data is sent. So these two addresses are added by this network layer, IP addresses. So these IP addresses have two schemes. Those are used. This is called as IP version 4. And recently the new technology of IP addresses is evolved, that is IPv6. So with these two technologies, the IP addresses are generated and given to every end device in the network, or every network device in the network, IPv4 and IPv6 logical addresses. So these are some of the features of network layer. Then services provided by a network layer. So first service is packetizing. So as I have told you, the data that is to be sent over the network is very large. So this large data is fragmented. Large data is fragmented. Fragmented means it is divided into a smaller amount of data called as packet. So this is the first service of the network layer, that the large data is divided into smaller packets. Then next is routing. So routing, I have told you that data can travel through different paths, and in order to decide the optimal path or the best path out of the available paths, some protocols are used, and these protocols decides the path. So this is the another service of the network layer. Next is forwarding. Now forwarding means, for example, say this is source, this is destination. Now the source wants to send a data to this destination, but there are intermediate nodes here. So data will travel through these intermediate nodes. Okay, now first source will send the data to this node. Okay, now this node is not the ultimate destination. Ultimate destination is this node. So what this node will do, it will check the destination address and will simply forward this packet to the next node, It will check the routing path, and inside the routing path, it will check which is the next node to which the data should be forwarded, so that it will reach to the destination. So it should not forward it to some other node which is not connected to this destination. It should forward to the appropriate node, so that data will get delivered to the destination. So this is called as the forwarding. So next is the forwarding service provided by the network layer. Error control, flow control, like in data link layer, we have understood what is error control and flow control. So this limited service is provided by a network layer also. So this is not a complete functionality of the network layer for error control and the flow control, but limited functionality is provided by this network layer. And finally, a congestion control. Now, congestion means these are the links. for transferring of a data. Now these links have some capacity. These links have some capacity to send a data. For example, say you might be hearing about the data rates. So we call data rate as 2 Mbps or 1 Mbps. Okay, so like this, we have a data rate. That means it is the capacity of the link, maximum amount of data that link can transfer. And what will happen if data will increase? If data increases beyond this capacity, if data increases beyond this capacity, then there will be a congestion in the network. And if there is a congestion in the network, then the network will slow down. Okay, now to overcome this disadvantage of congestion, there should be some mechanisms with which the amount of data can be controlled. Okay, so the different methods that are utilized in the network layer for minimizing this congestion are available. So this is the another service provided by the network layer. So these are the 5 services provided by network layer. First is packetizing, then routing and forwarding. Next is error control, then flow control, and finally congestion control. Okay, so this is all about the basics of the network layer. Now, important feature of the network layer is a IP addresses or the logical addresses. So we will study the IP addresses more in detail. Or most of the focus of this unit is in studying the logical addressing. So we have to study IPv4 addresses and IPv6 addresses also. So we start with IPv4 addresses. So an IPv4 address is a 32 bits long. IPv4 address is a 32-bit long. So you might have seen the address like 172.16.69.78. Okay, so this is the popular address in our college network. You might be knowing this. So what is this address of? Can somebody reply? What is this address of? If you have used the network in a college, then you might be knowing about this address. Okay, so this is the address of our cyber room. College cyber room. Okay, so this is a kind of address. So this address is a 32 bits long. Now, what is the meaning of this 32-bit long? So this first decimal is represented using 8 bits. The second decimal is represented using 8 bits. Similarly, third and fourth. So one decimal is represented using 8 bits. So total number of bits are 8 plus 8 plus 8 plus 8 equals to 32 bit. So this IPv4 address is a 32 bits of address. That means the IP addresses can be represented from 0.0.0.0. So this is the minimum number that can be formed with 8 bits. So these are the 8 bits. So this is the minimum number that you can form with the 8 bits. And what is the maximum number that you can form? So if it is all ones, then this will be the maximum number. So this is decimal 0. And what is this? Decimal 255. 255. So the last address that can be formed is 255.255.255.255. So this is how the IP addresses are represented. So minimum address is 0.0.0.0, maximum address is 255.255.255.255. You cannot have more than 255 number in IP address. Why it cannot be more than 255? Because maximum number that you can represent using 8 bits is this 111. And if you want to calculate, then this decimal position is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. 1, 2, 3, 4, 5, 6, 7, and 8. So if you add all of this, you will get this number as a 255. I think now you are familiar with how to convert number from binary to decimal and decimal to binary. You might have studied this in computer organization. Okay, so some of the logic I will tell you, but you are now well familiar of this. Okay, so just remember that Ipv4 address is a 32-bit long, either represented using a dotted decimal notation. So this is the dotted decimal notation, or can be represented as binary dotted notation. So Ipv4 addresses are unique and universal. Ipv4 addresses are unique and universal. Okay, now this you will understand when we will go further. The address space of Ipv4 is a 2 raised to 32. So total number of addresses are 2 raised to 32. Where this 32 come from? So this is the max length. Max length of IP addresses. So as IP address is a 32-bit long, that means total number of addresses that can be generated is 2 raised to 32. And if you calculate this number, this will be 4,294,967,296. So these many addresses are available. IPv4 addresses are available. So this is the notation of IPv4 address, binary notation and decimal notation. So this is binary dotted notation in which every decimal is represented using a binary format. So this is 128.11.3.31, or you can represent it using the dotted decimal notation. So this is called as dotted decimal notation. So for human understanding, we are always going to represent the IP address using the dotted decimal notation. Even if you type a command in your command prompt, then also you will get this kind of the notation. So if you want to check, let me show you. Command to check IP address is ipconfig. And if you see here, this is the IP address of my computer, 172.16.11.255. And this is the subnet mask that we are going to understand. And this is the default gateway, 172.16.69.78. This address I had told you, this is the address of the cyber room or a gateway of our college. Okay. So in this way, the IP addresses are represented in using the dotted decimal notation. Okay, now let us try to solve some numericals based on this. Change the following IPv4 address from binary notation to dotted decimal notation. Now these are the binary notations given to us. We want to convert this into dotted decimal notation. Okay, now to convert these numbers, simple technique that you can use. First, we will try to convert from this position. So this positions of the binary numbers are starting from 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7, and 2 raised to okay. So we have 8 bits only. So this first bit raised to 0. Just add this number. So here it is 1, so you will add this as 1 plus this is also 1, so add 2. Then this 4. Then this binary position is 8. 1, 2, 4, 8. Then there is a 0. So this is not required to be added. Then there is a after this is a 0. So it is not required to be added. These are all ones. 1, 2, 4, 8 that we have added. 16 is not required to be added. Then 32, 64, 128 plus 32 plus 64 plus 128. And what will be this number? So if you want to calculate it briefly, then this total becomes 255. Am I right? This total becomes 255. And only this 16 is absent. So simply subtract a 16 from it. So what you will get? 15 minus 6, 9, 4 minus 1, 3. 239. Am I right? So this is the 239 here. Okay, then calculate this. Second, so here you have to add 1 plus 2 plus 4 is not required to be added, 8. So this is 8 plus 2 plus 1, 11. Then add this. This is 1, 2, 4, 8. So 8 plus 2 plus 1, again 11. And finally this is 1 and this is 128. Check the here. It is 128. So 128 plus 1, 129. So this is 129 plus 11 plus 129.11.11.239. Okay, now similarly convert the second. So this one is all ones means 255, not required to add or anything. Then this is 1 plus 2 plus 4, 8 plus 16. So 16 plus 8, 24 plus 2, 26 plus 1, 27. 1, 2 and 128. So 130, 131. And this is 128 plus 64 plus 1. So 128 plus 64 is 192 plus 1, 193. Okay, so we will get this practice only if you will solve more examples. Okay, so let us check whether I have calculated it correct or not. So this is the answer for the first that we have calculated, 129.11.11.239. So it is correct. Next answer we have calculated as 193, 131, 27, 255. 193, 131, 27, 255. So both are correct. Okay, so you should have a practice of converting a binary to decimal and decimal to binary. And converting IP address is simple. Why it is simple? Because you know the binary position of each number. So just remember this and you will be able to answer every question. Remember these positions. First position is 1, then 2, 4, 8, 16, 32, 64, 128. And if all are ones, number is 255. Okay, now let me tell you how to convert this number 1100. Okay, now either you can add or you can subtract. So here there are more number of ones. There are 6 ones and 2 zeros. So we will use a subtract rule. So total, if all ones are there, then total number is 255. But these two are absent. What is absent? 1 and 2 is absent. Then that means 3 is absent. Am I right? 1 and 2 is absent. That means 3 is absent. So just subtract it. You will get 252 here. So addition would have required more time, but subtraction will require a lesser time. But if you have a lesser number of ones like 1000, 1000, then you can make an addition rule. So this is 128 and this is 1248 plus 8. So this is 136. So you can make use of the addition rule or the subtraction rule. Addition rule means whenever there are a minimum number of ones, you can use the addition rule. Whenever there are maximum number of ones, you can use the subtraction rule to convert quickly binary to decimal numbers. I hope it is now clear to you, or you can use your traditional method of converting from binary to decimal and decimal to binary. Okay, now the reverse of this, change the following Ipv4 addresses from dotted decimal notation to a binary notation. So first number is 111.56.45.78. Okay, so for converting this, first we will try to convert. Let me write here individual numbers 111. Tablet was not working, so let us check this next example. Change the following Ipv4 address from dotted decimal notation to binary notation. So we have to perform the reverse of this. So first we will try to solve this. Let us write the individual numbers 111. Now we have to represent this into a binary format. Okay, so we know that for representation of this number, we have how many bits available? 1, 2, 3, 4, 5, 6, 7, 8. We have total 8 bits are available to represent this decimal number. So always use the 8 numbers, 8 bits. Okay, now this 111 and the binary positions, write binary positions as 1, 2, 4, 8, 16, 32, 64, and 120. These are the binary positions. Now 111 is lesser than 128, so here it will be a 0. Am I right? It is lesser than 128, so here it will be a 0. Then next, 111 is greater than 64, so here it will be 1. So we have represented 111, out of 111, we have represented 64. So just subtract this. So what will be the subtraction of this? 36 plus 10, 47. Am I right? Yeah. So I think this is correct. Yes, it is correct. So we have represented now 64 and remaining are 47. So this 47 is greater than 32. So here it will be again a 1. So subtract 32 now from 47. So we'll get this as 32 plus 15 as 47. Then this 16 is greater than, so here it will be a 0. And here it will be all ones. 1 plus 2 plus 4 plus 8 is equals to 15. Am I right? So this is your 111. Now next decimal 56. Now use the same logic. 8 positions. So 56 is lesser than 128. It is lesser than 64. Greater than 32. So we are represented 32 now. Remaining is 56 minus 32 will become equals to 24. Am I right? Yes. Then 32, then this will be a 1. So we have represented more 16 out of this. Then remaining is 8, 1, remaining are 0. So this will be 56. 32 plus 16, 48 plus 8, 56. Now next is 45. 45. So 128 will be 0, 64 will be 0, 32 will be 1. So 45 minus 32, 13, which is greater than 16. So this will be 0 plus 8 plus, sorry, this will be 1 plus 8 plus 4 plus 1. Now count this 1 plus 4 plus 8 plus 32. 32 plus 8, 40 plus 5, 45. Similarly represent 78. So 78, 128 will be 0. 64 will be 1. Then 64, 78 minus 64. This will be 8 minus 4, 4, 6, 7 minus 6, 14. So this will be 0. Then this will be 0. 8 plus 4 plus 2. So this will be your 78 number. Okay, so in this way you can use the position method. So this is the position method by which you can firstly write the binary number, or another method by which you can convert into binary format is divide this number by 2. So this division will become 22, remainder 1. Then again divide by 2. So this division will become 11. Let me write it here. So another method. Okay, so this is other method of converting binary to decimal to binary. Divided by 2. So 22 2s are 44. Remainder will be 1. Then again divide by 2. It will be 11. Remainder 0. Again divide by 2. Remainder 1. Again divide by 2. Remainder is 1. Again divide by 2. Remainder is 0. And write the number in reverse order. You write this number in the reverse order like this. So this number is 101101, and we have to represent it is using the 8 bits. So these are 6, 7, and 8. So if you check this number and this number is the same. So either you can use a direct method or you can use this traditional method of converting binary to decimal. Whichever method you find is suitable, use that method to convert from binary to decimal or decimal to binary. But remember that represent each binary number in 8 bits. Always represent that using the 8 bits. Okay, so this is the answer for the first 0, 1, 1, 0, 1, 1, 1. So this we have represented correctly. 0, 0, 1, 1, 1, 0, 0. This is also correct. This is also correct, and this is also correct. And for this number, this is the conversion. You can try on your own to find this as an answer. Whichever method you find suitable, traditional method or direct method, you can use that method to convert this number. Only thing to remember is represent each binary number using 8 bits. So even though this number is can be represented with this 100010, but you should add 2 leading zeros here. Similarly, this number can be represented with 3 bits also, but you should be adding 5 leading zeros here. Okay, so represent each decimal number using 8-bit binary number. Okay, now next thing is to find the error, if any, in the following IPv4 addresses. Okay, now can you find the error in the following IPv4 addresses? So they have given, they have mentioned, or they have written these addresses with some errors. So we have to find those errors. So what is this number? 111.56.045.78. So this leading zero is not required. Leading zero is not required. So you should represent the numbers like 1, 2, 3, 4, 5, 6 up to 255. But you should not write 1 as 01 or 1 as 001. It should be a complete decimal number like 1. So if you want to write a 25, you should write it as a 25, not as a 0 to 5. So similarly, 45 should be written as 45 only, not as 045. So this is the error in representation of this address, that leading 0 is here, which is not required. Now, can you find the error in the next address? 221.34.7.8.20. Can somebody tell what is the error in this address? It is simple. Yes, somebody, please reply in the chat box if you can find the error in the second address. So this is the second address. What is the error in representation? Do you find anything wrong here in this address? How many decimals are there in IP address? Yes, extra decimals are added. Not extra bit, extra decimals are added. So IP address is of 4 decimals. So this is the first decimal. If you check this address, it has the 4 decimals. First decimal, second decimal, third, and fourth. IP address is always of the 4 decimal because it has 4 octets of 8 bits. So that's why in this address there are 1, 2, 3, 4, 5 decimals. So this is the error in this address, that it has 5 decimals, but it should have 4 decimals. Then what is the error here in this address? In address C? Is there any error? Can you check? So here is the error of max decimal. What is the max decimal in IP address? Maximum decimal that we have studied. IP address starts from 0 and maximum decimal of IP address is, yes, maximum decimal of IP address is 255. Decimal cannot be greater than 255. Decimal cannot be greater than 255. But here decimal is given as 301. Here decimal is given as 301. So this is the error in this address, that the 301 is greater than maximum decimal, which is 255. Okay, now the last address. So here the error is address can be either decimal or binary. Address can be represented either as a decimal or a binary number. So you can't make a mixture of a decimal and a binary number to represent the address. So here is a mixture. This first octal is given as binary, and remaining octals are given as decimal. So this is a mixture of binary and a decimal. So that's why this is the error in this representation of the address. Okay, so what things we have learned in IP address? IP address is of 32-bit, represented in terms of 4 octals. Represented in terms of 4 octals. So there are two notations of the IP address: binary notation and dotted decimal notation. Binary notation and dotted decimal notation. In dotted decimal notation, minimum number is 0 and maximum number is 255. Minimum number is 0 and maximum number is 255. I think this is sufficient for today's lecture. I will share one more video of video related to this IP addresses, and you must watch that video in order to learn more about the IP addresses. So we have lesser time to complete our syllabus, so we will complete the syllabus in online mode as well as in the offline mode. And this is the most interesting part of your computer network, learning the IP addresses. So you should not miss this learning opportunity of the IP addresses and practice more of the questions. If you take your GATE examination, you will get more questions based on this network layer or IP address scheme inside the GATE examination, or any technical aptitude examination that will appear. There will be more questions based on the IP addressing schemes. Okay, so for that reason, you should be practicing more of the IP addresses. So we will stop with this. Okay, so the same solutions are given. There should not be a leading zero. There can be no more than 4 numbers. Maximum number cannot be more than 255, and a mixture of binary notation and dotted decimal notation. These are the 4 errors. Okay, next lecture we will be starting with classful addressing. What is the meaning by classful addressing? Classless addressing, that we will study.